We're going live now. Okay, so I think we're live. So welcome everyone to computer science. Welcome to the future of computer science. So we're going to take you through an insight into what computer science holds, why it's such an exciting and interesting subject, and the current kind of things you can do with computer science and the technologies around it. So just before we get started, at the top you may see a stream going across which talks about menti.com. We're going to try and make this a bit interactive. We're going to have a few questions for you. So if you can download on the App Store or the Google Play Store the Menti or Mentimeter app, or you can just go to menti.com on a computer or a tablet or a device and use the code. You can see 6776410. And you'll be able to engage in some of the Q&A we're gonna go through as we progress through this talk.
Sorry, John. Those Menti questions, they'll be on the slides, and it will prompt you for when to respond. So don't go flying through them. We'll have moments where you can respond. Yeah,
there we go. Thanks, Ashley. So, okay, so a little bit about who am I? Well, I'm Professor of Robotics and Autonomous Systems at the University of Hull. Did my PhD in computational neuroscience and robotics. So basically looked at how the human brain does things and tried to get robots to do the same things. Got a degree in computer science and I got another degree in electronic engineering. Who is he? I'll let him introduce himself.
Who am I? Slightly chopped off there in the frame. So I'm a lecturer in computer science. So I lecture in things like data mining, data science, machine learning, what I like to call magic. I also have a degree in computer science, sadly not two, as John has, and I specialize in security and machine learning.
Okay. So, what are our interests? Well, there's our lecturer of the future, as it were. So this is Pepper, one of our robots, who I had give one of our first lectures to our students.
Teaching the fundamentals of robot systems.
There we go. So some of our interests are in robotics, as Ashley mentioned, machine learning, AI. We've got interests in security. We do a lot of work with the Home Office and things like that as well, using AI, machine learning and robotics as well in those applications. And we do lots of virtual reality as well. And we both have a big passion in drones, just for kicks, just because drones are fun, drones are cool. So we do a lot of drone stuff as well.
When we're not crashing them, that is.
That's true.
When they're intact and working.
When they fly, yeah. When they've not landed upside down in a tree. Okay, so one of the things I like to say to students, some of our new students, when they arrive on our program is, why did you choose computer science? Tell us something you liked about computer science, why you chose it as a subject. So this is what we ask our first years when they come in, and here's a word cloud of some of the responses that we received from our current first year students. Computer science is the future. It's interesting. They're interested in the security aspects of cyber security, which is a big area at the moment. Employability is really good in computer science. The salaries computer science will bring, it's innovative, it's the future. And one of the things I like most about this, obviously, is it's cool. Computer science is definitely cool, and we'll show you some of those exciting things.
It is very cool.
As we go through.
We might be a bit biased in this regard, though.
So, why computer science? So there's three kind of broad areas around computer science that most people would fall into that category. So computer science spans theory of programming to cutting-edge developments in technology and technology solutions. And as a computer scientist, you would build and design software. As a computer scientist, we develop ways to solve computing problems. So we try to find ways of making computers better, more efficient. And the one that's close to my home and my heart is devise new and better ways to use computers to solve other people's problems. So we use computer science to look at how we can solve climate change, how we can prevent flood and challenge flood risk, and lots of kind of areas like that. Now, computer science moves forward at such a rate, it's one of the fastest moving subjects. you could ever wish to be part of. And when computer science kind of started getting off the ground around 1940, that's the kind of technology you might have seen. What I'll do,
I think my video's in
I will just pop us away there for a moment. That's the kind of technology you might have seen in 1940. That computer could probably carry out 8 operations a second, which is faster than a human, adding 8 numbers together. But then if you come to today, 2020, that's the technology we're faced with now. We've got a globally connected planet. We can send an email and within a second it's the other side of the world. We've got virtual reality. We've got devices that will allow us to use brain-computer interfacing. All sorts of kind of things are happening there in computer science. So when we're teaching our students, when we're doing a lot of work at the university, we like to work with industry. We like to work with business as well, and we do a lot of projects where we're helping industry solve some of their problems, some of the issues that they may be facing in their business. And one of the projects we worked on at the university a number of years ago was called Drop from Heights, and we were supporting offshore wind turbine workers. So in a wind turbine, at the top in the big nacelle where the blades are, you have several workers that will go up there and spend their shift working in that nacelle, and it's a dangerous environment. You know, things can go wrong, and we might have to evacuate them. And it's quite a way up. It's over 100 meters high. So what do we do? Well, we built a virtual reality simulator for that, so we could test reactions of people being harnessed up and down a wind turbine to see how they cope with heights. And to show you the system we have, there we go. So we took one of our PhD students and dropped them from a height. So we have a harness at the university, a rig that we can put people in that gives them the feeling, the experience that they are off the ground, and then in VR they get the presence that they feel like they're actually in that nacelle. And what I will do is I will pop us away again for a second, because there's a great video we have here now which gives a bit more of a feeling of what that looks like when you're in the virtual reality. So here you are on the harness, only a few inches off the ground. You get winched up, there's a fire in the nacelle, and we have to evacuate you. And there you go. And it gives that, you know, people who might be a bit afraid of heights, we can use this to do aversion therapy. We can support them. We can let them know what it feels like when they're being dropped down from that nacelle onto a ship that might be coming in to rescue and support them.
And it's all in a safe way. So, you know, dropping people from real wind turbines is costly, it's dangerous, and all of this avoids that and helps train people in a safe way.
Absolutely. So that takes us on to the next aspect of what we're going to talk about around computer science, which is around a big area of ours, which is artificial intelligence. And if you go to menti.com and type in 67764010, you'll be able to give a result on whether you think artificial intelligence is a danger. The answers are yes, no, only in the wrong hands. So what we'll do, we'll leave that there for a moment. We've got a couple of respondents come in already on that to see what you think of artificial intelligence.
So it's worthwhile pointing out that the word danger here is particularly vague, right?
Yeah, so it's your interpretation of what that might well be. So we're getting some more results in there, which is great. We've had a few more come in. So what we're getting is a consensus that artificial intelligence may only be a danger in the wrong hands. So what does the wrong hands mean? Well, we'll certainly show you that as we go through this presentation.
Oh.
We've got a few people coming in and said no.
Definitely no.
Yeah. So that slide will stay up. That poll question will stay up. So you're free to answer that as we progress through the slides, and we'll be able to come back and look at that data and talk about it in a few minutes. What we'll do is we'll move on to the next slide, and there'll be a few more mentees as well. So those who haven't had a chance to engage in this one, there'll be a lot more questions as we go through. But this is kind of what you might perceive as artificial intelligence of the future, okay? So we've all seen Terminator. We think of the T-800 being the kind of the AI that's going to, you know, Stephen Hawking, Professor Hawking spoke about how AI might be the end of kind of mankind in the future. But we'll talk a little more about the niceties of what AI can also achieve. And this might be actually the AI of the present. This is what we might think of disembodied AI. We've all got smart speakers at home and TVs that are voice activated and those kinds of things. So this is how phones that are activated as well. So there's a lot of technology out there now which we are using, which is embedded with AI. And it's not just about physical machines. It's not just about the T-800, but it's about how we interact with the technology as well. And it's about physical versus disembodiment and embodiment. So whether an AI is in a physical robot, or whether it's in a speaker, or it's pervasive, we can't see it, but it's there and around, and we can make use of it. This is probably the most common aspect of our smart speakers. I won't say it because I have one here and it'll activate, but we know the name. And there have been over 100 million of these devices sold worldwide. In total, including the Google Home and Microsoft's version, there's over 200 million of these devices have been sold globally. And they're used for all sorts of things. So people use them to set timers, people use them to play music, people use them to communicate with each other, ask questions, tell jokes. There's all sorts of different things people do. People also propose to them. So the Amazon Echo has had over 1 million marriage proposals to date, according to the statistics, and has turned all of them down. I'm still hopeful. I'm still hopeful.
Not even one.
So, taking kind of AI technology, we can move that into more kind of everyday areas of our lives. And one of the things we're doing at the moment with our students, and one of the things we look at is driverless cars. And here is a video of the project, the assignment for our first year students, where they're all given a robot and they're asked to program that robot to act autonomously, driving around a road, detecting the road, detecting other vehicles, detecting roundabouts, detecting speed changes, crossroads, all sorts of things. And that informs, that builds up the skills that are needed to then move on to learn about the more advanced topics of AI that we'll cover as we go through, and how people can employ that technology into everyday aspects of their lives. So here's an actual autonomous vehicle. This is the Waymo, which are now starting to be used on actual physical roads in the UK. These have been granted permission to be tested over the next couple of years. And what we have here is some dash cam footage from a colleague. This is in Hull. This is taken at the bottom of Hull near Hessel. And there's some footage here. You might have a dash cam recording items. And there's a number of questions we can ask about that. So, see in that video, we could ask the question, how many cars were there? You know, how many cars did we see? How many trains went past? Could be a question that we might want to ask. So let's see if we can get some mentees up on this. So in that video,
sorry, John.
It's okay. I was going to say, how many trains do we think might have went past on that?
So when a driver's driving down a road, there are 1,000,001 things that we constantly feed into our brains that hopefully goes into the decisions that we make. And not everything kind of makes it in. So having watched that clip, we're now going to see what your brain picked up on, and maybe what it didn't pick up on.
So there we go. We've got 1, 2, or 4. Not getting any activation on this. Oh. hang on, let me just, sorry, we're having a few, there we go, look at that. There we go. So, none, 1, and 4. Okay, so there's some of the responses that we think of how many trains might have went past. Okay, so the next question on that then, that's quite interesting. The next question we can ask is, how many pedestrians were there in that video? How many did you see?
I don't even know if I could quantify it, John.
So one of the things about this as well is when you're driving a car, you're focused on particular aspects of your driving. You're focused on what gear you're in, how fast you're going, some of the signs around you, other cars around you, and we can't be aware of absolutely everything that we might see. We can't be aware of all the obstacles around us. Oh. Sorry, apologies. Yeah, it's just there we go.
Oh, there we go.
So we've got some people saw none, some people saw 2, and some people saw 3 pedestrians. Okay. So the kind of final question, did you spot the ambulance? So nearly everyone
question what I've seen.
Yeah, exactly. It's kind of the way we ask the question as well. Did you spot the ambulance? I think everyone there has said no, they didn't spot the ambulance. Oh, I think there's, yeah, I think that's it. So here we have a computer that can identify all the items, identify pedestrian. There's one on the left you may have missed as we come around the corner, all the cars. If I pause this video and take us back on this one, just ahead by the crossing is a pedestrian. There we go, on a bike, and it picks the bike out as well. There was no ambulance, so I was just trying to test, see if everyone's paying attention. There was no ambulance in this video. And yeah, so what we have is AI that can, in real-time analysis, so this video can be processed in real time, can identify everything around for us. And that's why autonomous cars are quite gaining a lot of ground, because they're constantly alert 24/7. And don't tire, don't miss things. Here's some footage we did at the university as well. So we've got another dash cam footage. Ashley, do you recognise this dash cam footage?
I believe that's my dash cam footage, John.
And what we've got is an overlay using artificial intelligence, machine learning, which can pick out the exact correct lane the car needs to be in. So what the AI is doing is the AI is telling us which lane we should be in if we're driving on this side of the road. It picks it up. So this is not us saying, let's highlight the lane. This is AI telling us where it thinks the lane is and where it should be driven.
So it's not highlighting the road on the other side.
Exactly. So the other side of the road, which is a road, similar features, it's not identifying that. It's only identifying where it knows we're allowed, based on rules it's inferred from the video, that we're allowed to actually drive. So that shows you some of the kind of strength, some of the powers of AI. Okay, attention. So we've got another few videos coming up, which we're going to talk a bit about attention in, and hopefully the Menti questions will work in this, and then we'll finish on some current advances in artificial intelligence and how we can use AI for some interesting topics and ideas. So
cut our videos out, John.
I will take us out the screen. So there we go. So count how many times the players wearing white pass the ball. So are you ready to watch this?
Count how many times the players wearing white pass the ball. Count how many times the players...
There we go. So the question for the Menti, let's activate that slide, is how many times the players wearing white passed the ball. So how many times do we think that was? So we've got a few results in, a few scores on the doors. I'll bring myself and Ashley back into the presentation for now. So the majority of us think it was 16. I think 16 times did the players in white pass the ball. We've got a few people think it was 14, and then no one for any of the others, which is fine. So let's see what other questions we might have. Got a few more. Yeah. Let's give that another second or so.
So they're all roughly in the same, I don't want to say ballpark, but ballpark.
Yeah, ballpark. Okay, so before we do that, let's put another question up. What pattern was on the balls? What pattern was on the balls? Do we think? So let's wait for some results to come in. So this is about attention. Okay, so we have stars, triangles, stripes. No one's gone for spots. That's quite interesting. So let's go to our next question. How many players were on the team wearing black? And we've got quite a split here from participants between 3 and 5. Okay, and I think there's maybe another question. Let's just wait for this to filter through.
We should have probably had I don't know as an option on most of these jobs.
Yeah, quite.
So for the ball pattern one, I wasn't sure.
And the other question is, did you spot the gorilla? Okay, so we have no one says they didn't spot the gorilla. So everyone that replied to this spotted the gorilla. Okay. Well, let's watch this video very quickly.
For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. For people who haven't seen or heard about a video,
Okay, so what we can then do, so why this is important, is we can actually apply, again, AI, machine learning to this, which can then be used to track the number of skeletons, the number of people as we're going through, and can, oh, bear with me, it's because I'm a bit quick there to click on it. Can also pick out the changes in the curtain as well. So we have up the top, we can pick a particular pixel and we can monitor that pixel as it changes. We can pick up the gorilla as the gorilla enters in to the arena. And we can do all that with automated systems. And AI can do that for us.
Noting, we're not just detecting people here, we're detecting their entire pose, so which way they're facing, how they're like using their arms, their feet, where
their elbows are, where their knees are. Yeah,
exactly. All of this in real time.
And just to answer the questions, there were 16 passes. So if you thought there were 16 passes, that's correct. There were 3 players on each team, and it was stars that was on the balls. Okay, so where does this leave us then? So this is kind of the kind of crux of where we want to get to in this talk, and takes us into the kind of last 5 minutes or so of what we want to talk about, which is security aspects. So what we can do here is we can apply these technologies, we can apply this AI, this information to everyday scenarios. So here we've got a train station, lots of people bustling around in a train station, people with suitcases, people with bags and handbags and carrier bags. And by applying AI, what we can do is we can track those individuals without having to have someone watch them and monitor them. So it can be very much, you know, kind of confidential, and we can keep control of the data. But also, if you look at the top right, we can actually identify people carrying handbags and suitcases and backpacks. These are all segmented out on the images and picked up for us by that technology. Ashley, do you want to quickly talk about this?
The games part, which might interest a lot of you. So with all this artificial intelligence and things like that, there has been a push to do things in the gaming sector, which millions of dollars of research has gone into effectively making AI opponents in video games challenging. So often in competitive games, they have ranks, and you know they have sort of grandmaster is usually the big one, that the top rank. And so there's been a lot of development using a technique called reinforcement learning. We take a baby AI and we train it, we make it sort of play many games against itself and other variations, and it learns the best strategy, the best things to do. And companies have applied this to games like StarCraft 2, which you're seeing here, Alpha Star by DeepMind, and also Dota 2, if any of you play that. So what you're seeing on screen is actually what the AI sees. And it's not a magical AI that knows everything. It has the same limitations as a player. It can only see what's on screen. It can only click as fast as a human can click. And on the right, you'll see that it's predicting itself to win, and it's predicting itself to win constantly. So it's not yet thinking it's going to draw or lose. Now, why do we waste millions of dollars in getting better games? Well, because the techniques that are being developed here, these are only 2-3 years old at the most. These are applicable to way more than just games. They're applicable to robotics. So how a robot might delicately grab objects and place them, which has implications in industry for automation of practices and things like that. So whilst this is great for people who play video games, it's also great that the techniques here are towards a generalized approach where we can apply it to many problems. Just so happens that it's in a fun way.
Okay, jump straight in there to that one. Okay, so that might have woke some people up. So thanks, Ashley. So I'll keep myself and Ashley off the screen for the moment. So the final thing we really want to talk about is other applications of AI. So we did this last night just to show what could be done, you know, in a couple of hours of coding. So we recorded the video last night. I recorded, sat in this chair I'm sat in now. I recorded 10 seconds of myself doing the kind of Baby Bell kind of bar sound. Just recorded it on my phone and put it through an algorithm. The image on the right is exactly that. It's an image. It's just a picture I downloaded off the internet, just a static image. And what we can do with AI is, and if you look at the features, if you look at the eyebrows, if you look at the mouth, the nose, the furring of the brow, it all matches up with exactly what I'm doing on the left.
So these are techniques that are very new. We're talking 2 years. This technique itself is less than a year old. This is how quickly this field is developing.
Yeah. So what I can now do is I can now have the Terminator deliver my AI lectures. And you know, we can overlay our voice. I might not quite sound like the Terminator, but yeah. So we can apply that technology to everyday scenarios as well. Making movies, we can now take characters and repurpose them and repose them from an image, from a simple static image. We can apply this technology, and I believe there's another interesting one next. Oh, this didn't work. There we go.
There we go.
So Ashley deserves an award, I said, apparently. Well,
you did, John.
Did I say that?
Right
Did I say you deserve an award? Did I say that?
There's definitely a video of you saying I deserve an award. It's evidence.
Okay.
Now you've all witnessed the I think we should do.
Okay. So that's Ashley trying to get himself an award. By taking a picture of me from a website, so that's my staff profile on the website, and applying exactly the same technology. So let's watch that again.
Hi, my name is John. I think that Ashley is the therefore, I thought that it's evidence. And now you've all witnessed the award. I think we should do.
Okay, and the voice isn't quite the same, but there are techniques for actually simulating people's voices. We don't have time to talk about that today, but you can also take some recordings of people's voices and synthesize anything you want them to say. So you can now make videos from a static image. You can superimpose audio on top of that, which is their voice, which is all done from AI. Now, these are early techniques. These have only been around for a couple of years, these techniques. But when you think about what it might mean for the movie industry, you know, for lots of different kind of sectors, in 2, 3, or 4 more years is quite mind-blowing. Ashley's got a quick thing he wants to mention about COVID detection, I believe.
So very, very recently, and you might have seen this in the news, so some of this machine learning that we're talking about, they've managed to, from just a cough alone, determine with, I think, 97 or 98% accuracy whether somebody is going to test positive for COVID-19. So without the test that you need to go to a test center for, just from the sound of somebody coughing, I think 3 times, 98% accuracy in terms of whether they have COVID or not. And that's the power of these machine learning techniques, and this is the future.
So it's not all just about trying to get an award from your from the department for creating videos and pretending to be the head of the department, but it's actually about other applications as well. So you know, the pandemic we're in at the moment, being able to apply these techniques to those challenges and come up with such high accuracy, you know, we can start building on these AI techniques, and when we have future world problems, we can use AI, computer science, fundamentally to address those. And as I mentioned earlier in the presentation, you know, the third point about what a computer scientist is, it's taking computer science and applying it to solve other people's problems. So to solve medical problems, to solve climate change, to solve carbon neutral agendas, you know, to make sure that we're carbon neutral. It fits into all those areas, absolutely massively. And that's our presentation. That's our half an hour. I think we're slightly overrun. I apologize. But hopefully you found that interesting. Hopefully you found that kind of an insight into what computer science can do and what computer science is about. You know, if any industry, you know, businesses are kind of watching and listening, or watch this on a catch up, you know, how you can apply these techniques to your business. And for anyone looking to go to university and study computer science, think about what computer science might be like in the next 3, 4, or 5 years. When I went to university, I took a big computer with me. It was, you know, it was my pride and joy of a computer. I went to university 20 years ago. And now that processing power is available in a Raspberry Pi, you know, the size of a credit card. And that's how fast computer science moves. So thank you very much.
Thank you very much.